Hello, I'm Brayden, and I'm going to be presenting case 6, which is on the topic of linear programming. All right, some background information on the topic. So, linear programming is the mathematical approach to maximize or minimize a linear function of several different variables. So, yeah, linear programming is often used by managers because they want to make the best possible decision in terms of like a variety of settings that they could be in. All right, so for case 6, we were once again continuing our work with Amazon. So we have two sets of revenue from retail and AWS, which was Amazon Web Services. So those are the two methods of revenue that we were working with. So we were given a budget on resource hours for both of them. So in which Amazon will use to decide what is the better method to use for their corporation. So for part one, we had to choose the correct template in Excel in the Excel file that um, we wanted to use, or not wanted to, but there was a correct one. I think there was like three of them. So we could figure this out based off of the data provided and then a correct number of options that we had. So in the instance of maximizing profits, since we're dealing with revenue, that's what we're going to want to maximize. So after that, we can label our constraints, which were in the instructions. So it would be technical support, customer service, advertising, the AWS minimum, so the minimum amount for the Amazon Web Services, and then we have the retail non-reg. All right. So after we can apply the number of resources available to each corresponding constraint based on the data. So for technical support, we had 100,000 hours available. Customer service, we had 200,000 hours. Advertising, we had 500,000, and Amazon Web Services minimum, we had 25,000, and then the retail non-reg would just be constant at zero. So uh, all right, so here's the part now where we want to, after we've done all that, we have to figure out the inequality sign that we want to use, or we want to use based on what is given. So here, as you can see, technical support, customer service, and advertising, and then you have AWS minimum and retail non-reg, which are the two that are different. So Excel's pretty good about this because it tells you if it makes sense and it will be green, which means you're good, but if it's incorrect, it will be red and it'll tell you that it's wrong. So, and Brian will describe um, the solver and how to get the optimal solution on the next slide.
Okay, picking up where Brandon left off. We next want to plug in the data into the solver located on the Data tab in Excel. Do this by inputting the objective function, changing the variables, and the constraints. The point of this process is to receive the optimal solution for part one. Here on this slide, we take a look at just the final product of part one. Just these are our answers, and that's what we got for part one. All right, so moving on to part two. Part two requires very minor change. Instead of 200,000 hours available, there was only 100,000 hours. We simply just use this information from part one with this minor change in customer service to find the optimal solution with the solver. This resulted in not a significant change. Oops. Okay, so here's our final product of part two. And while taking a look at this, we can see that with the customer service hours reduced, there's now a slack in customer service. And the optimal function went down by 100,000. And yeah, so that's the final product of part two. Thank you.
All right, now we got part three. Part 3 asks us to consider that Amazon has decided to do a minimum of 25,000 for the AWS since the growth is slacking in that area. We must consider that the customer service is no longer changed and remains at 200,000, and that's not really going to change much once again. You can see that in the third line down, it stays at 200,000, and that pretty much stays constant throughout the entire sheet. After that, in part 3, we have to create a sensitivity report with those findings, and then we can create the sensitivity report using the what if analysis tab. We must insert the input and output range of what we want to include in the report. And this is what it's going to look like. We're going to find values like the final value, reduced cost, objective coefficient, allowable increase, and allowable decrease. And in conclusion, as shown by the sensitivity report, you can see that we have access to allowable increase, allowable decrease, and shadow prices, which were not present before.